Okay, so we can have multiple interfaces that go into one class by just saying implements interface 1, interface 2, interface 3. If we include fields, so the interface can contain field declarations, but all fields in interface are treated as final and static. So if we include them, they will be static and they will be have final. They will be considered as constants. So if you do include those, make sure you write them all uppercase. If we do an instance, an interface, and a UML diagram, it's going to be a dotted line. The dotted line will basically say that we are implementing this particular, and we always put interfaces in less than, interface, greater than, and then we write the name of it. Again, interfaces always have a able at the end of it, so here's relatable, and then we show the methods that we expect to see over here, and sure enough, there's equals, there's is greater, and there's is less. Polymorphisms and interfaces, just as you can create a reference variable of a class type, Java allows you to create a reference variable of an interface type. An interface reference variable can reference any object that implements the interface, regardless of its class type. So let's take a look at retail item. So down here is retail item. We can see it's got public interface retail item, and we've got public double get retail price. So whoever implements this interface will have a method that's called get retail price, and it returns a double. Now we're going to basically, let's open up compact disk. So let's look at compact disk. And there it basically has public class compact disk implements retail item. So we can see that the compact disk has 3 instance variables: title, artist, and retail price. Here is our constructor. We bring in a string double and load those 3 instance variables. We have string get title, string get artist, double get retail price. So there is our retail price method that we are contractually required to have. It returns a double. Sure enough, it returns retail price. If we look at DVD movie, it implements a retail value as well, and it has 3 instance variables. Here's its constructor, where it loads those 3 instance variables. We've got get title, and here's get running time, and look, here's get retail price. We are required to have this get retail price. I think is there one more? No, that was it. If we open up polymorphic interface demo, we can see that we have compact CD, NuGet compact CD, greatest hits, Joe Looney Band, 1895, DVD movie, Wheels of Fury, 137, 1295. So this guy had 2 instance variables. This guy has 3. Oh no, this has got 3. This has got 2. This has got a string double, and this has got a string integer double. We could say get the title, then show retail price, and we could basically then whatever item we pass into it, and it doesn't care, because why? They're both retail items. Notice how we pass a retail item, and since it's an interface, we implement from it. That's fine. So even though we pass we're passing a D. So down here, I got cd.getTitle and movie.getTitle. And down here, I can call show price. Where's show price? Do we have another? No, that's it. Where the heck do we call show? Oh, here it is, right here. Show price movie. And up here is show price CD. So even though they're two different classes altogether, since they both implement retail item, I can just say pass retail. There's the polymorphism, and it's going to receive it as item, and it's going to basically utilize the get retail price method. Now, this particular method doesn't know anything about getting the title or getting the runtime of the movie or anything like that. It doesn't know the artist, it doesn't know the title, but it does know get retail price. Because if I tried to do this, if I basically hit the period right here, the only thing that it basically has is get retail price. It has a toString. It has equals. Remember, those come from the object class. It's got hash code. It's got notify. All of these methods, except for get retail price, come from object. Get retail price is the only thing that basically is in the retail item. So, since it's not, so if I change this to CD, what's it called? Oh, compact, yeah, lowercase CD. If I just call this CD, notice I get a red squiggly line because guess what? When I say show price movie, it doesn't know what that is. And so I have to basically call this retail item. And then it basically works just fine. So that's the polymorphism of using an interface. Any questions on that? Let's take a look at displayable again. And there we've got that. This is a default method. Let's take a look at person. And here we basically, that implements displayable. And this particular class has one instance variable, and it's a string name. And it's got, all it has is a constructor. Person string name equals n. Okay? Now, since displayable, it has a default void display. That's kind of like, since it implements, it's kind of like inherited this. It's got basically a void. So we didn't have to include that method in our person. That method is already there. That method display is already there. So now when we open up the interface demo default method, there's where I create p person equals new person Antonio, and there's a p.display. And so when I call that p.display, it will display Antonio. Or no, displays that this is the default method because that's what's in displayable and that display method. Okay. If we go over to page 681, Oh, I went too far. Oh, maybe it's not in this book. Okay. Wow. Okay, like this, that's not in the book. Okay, so on page 681 we have this thing called anonymous interclasses, and it says an interclass is a class that's defined inside of another class. So we have a main class. We can actually create a class inside of that class. An anonymous interclass must implement an interface or extend another class. So let's take a look at int calculator. Int calculator. And here we've got public interface int calculator. And guess what? We must create, whoever implements this interface, we must create a method called calculate. It's going to return an int, and it must receive an int and a variable number. So when we implement this interface, we are signing a contract that we are going to have a method called that. Let's open up anonymous class demo. Let's take a look at this. So I create a local variable called num. It's an integer. Here's my scanner keyboard. Now here's where I create an inner class. So this is my class. I'm going to create a class inside of here. This is how it looks. Int calculator square is equal to it's instantiated as a new int calculator. Notice I've got an open brace right there. Look at this. I go ahead and have a method from that interface. There's my calculate. It's returning an int, and I'm receiving an int number, and it says return number times number. And look, there's a closing brace. There's a closing brace. Boom, done. So we now have this object sitting there, and we've got a method built inside of it, right? So look at that. We've created a class and a method right there. That's our inner class. I come down here and say sysout print, enter a number, num keyboard next int. So I throw that in the num, and then I say sysout. The square is square dot calculate num. What is square? That's our object right here that we created in that class. Calculate, that's the method that's basically right here. So it's kind of a nice way to have create a quick object inside of another object. We don't want anything too complex, and then we can actually just call that method by passing a number, and it's going to basically call this method and come back. Any questions on that? Now, we can actually shorten this a little bit. This thing called an interface and a lambda expression. So let's take a look at int calculator again. So there's my int calculator. Okay, we've seen this before. If we implement this, we have to have a method called calculate. We're going to return an int, and we're going to also pass in an int. Let's take a look at lambda demo. So here is our local variable int num. Here's our scanner keyboard, and here is where we create an inner class. Look at this guy. Here's the name of the class. Here's the name of the object. And we got x goes into x times x. There is no calculate, is there? Guess what? since we're doing the int calculator, it basically knows that it's implementing from the int calculate. See that int calculator? So we're basically we're not so much creating an instance of the int calculator, but we're creating its own object called square, and this is the method. Since there's only one method in int calculator, this is the guts that is put into the int calculator. I'm sorry, the calculate, the method calculate. Seems weird. I don't like it myself because it's too much of a shortcut. I have to really kind of break this. Every time I see one of these, I have to really break it down to figure out what's going on. I think this makes a little more sense. But look at, you got 1, 2, 3, 4 lines of code as opposed to just one line of code. But again, I think it's a little intimidating to basically deal with that. But it's also kind of slick, because what we did is we took these 4 lines of code here and just made it one line of code. This is called the lambda. And then I ask the user for a number, and then I basically say square.calculate num, and this is the guts of the calculate num. What do you think? Kind of squirrely? Okay. It's kind of weird, I know. Like I don't like it because it's not intuitive. When I look at it, it doesn't make a whole lot of sense. But it's pretty slick. It saves a lot of coding. Like I said, I like this better because I can actually see the method right here. This one I'd have to really go back and go, okay, I'd have to go back to the int calculate to see, oh, yep, okay, there it is. There's the calculate. And when I type period, I see the calculate right there. That's another weird thing, is this is the only place we see calculate. And again, we get pretty much the same exact results. You type in an integer, and it brings back the square of that. Any questions on anything we covered tonight? Okay. We can do another lab, or we can call it a night. Okay.